here, this is just a piece of poplar, it's just what I had kicking around. When I do a ton of spindle turning, a lot of it. So in my shop, I have two types, or two hardnesses, I should say, of lead pencils. For general marking, like I'm going to mark here 5.5 inches down for my pummel cut, right here, and square that across. And for that, I'm going to use a standard number 2 pencil, right here. So that's going to be, this will be left square, pummel cut right here, this is going to be turned. Now, for marking the diagonals, particularly in a situation like this, and what Jan said brings up the point, you know, if you've got a dull pencil or a pencil that's leaving a really wide mark on there, you can't be accurate. So I go to the 2.5 hardness, a harder lead pencils, and works much, much better for doing a layout like this. And again, this is one of those, I think they're up to $5.95, they used to be $4.95, center finders. But a spindle turner will always do 4 around. In other words, this is a center finder, it's going to find the center. So if I go here and here, I've got an X. The problem is, I've got an X for sure, but I haven't got the center, because when this pencil goes against here, it's not like using a knife to draw that line. So you go 4 around, and you actually end up with a little small square in the middle. That's the center. And in this type of an application, that's going to be really, really important. Any application where you've got pummel cuts, this becomes really, really, really important. So we will take and mark this out with my 4 around, and I just had a brain fart. I said, I bet I didn't bring a scratch awl, and I didn't. I'm just going to steal the cap here. I had one in my hand, but I used it for something else this afternoon. The old yellow handle one.
Is that the best one?
WW2, no.
Okay.
This came out of the old sheet metal shop, and it's the best one that we have. So we're going to take and just mark the points of these. And I'm just going to quickly send this around. The center that I use a lot, you can get regular drive spurs, but when you're doing any type of offset work, this is called a steb center, S-T-E-B. I don't know, I guess Joe Steb invented it, I don't know. But you see that instead of the 4 points that you're normally used to, you get this sawtooth around the outside edge. So when you do tip these things off axis, you get a lot of contact here. And the center point is spring-loaded. So when this goes in and goes against the wood and depresses, it still only makes just a little dimple. And I don't know if you've seen those before, but we pass that around just so you can see that. Okay. So now what we'll do is down here on the foot, using my famous, I'm going to just pick a corner and go with a 3/8 offset right there. And I'll mark that center, and that's going to be our offset. And then typically what I do is, particularly on a layout like this, I'm just going to mark this so that I know that this is a direction that I offset here. So when I put this offset down here, I want to go to this side over here for my 1/8 offset. And I'm actually going to go closer to 3/32 than I am 1/8 of an inch. And those are my marks. Okay? So, we are ready to rock and roll here. I didn't even check to see if this is. Life is good. Life is good. Okay, how's the steps doing? That's fine. Yeah, I'll turn it around out. I'll send it back around after, just so you can see what it is. Oops. Just move that in. So I'm going to put this right on center first. And there we go. Now the other really big deal about the step center is, for the spindle turner, is that as you're turning, all you got to do is reach over here and back this up a little bit, and you can stop it. So, like when I'm turning spindles like this, my lathe will go for hours and never be shut off, because you can actually change spindles out. It's the greatest thing since sliced bread, as far as I'm concerned. Now, for you bowl turners, we usually, or most people, turn relatively slow. But the reason for that is, it's all about the surface contact, the amount of wood hitting the tool as it comes around. For that reason, small like this, we're going to have to go faster to get the same surface contact that we would, say, even with a 10-inch bowl, something like that. So, and I have a one-way lathe. It does not have a digital readout. So people say, how fast are you turning? I have no idea. I don't know. Just about that fast right there. We're about 1372, which for a lot of work is probably a little bit slow even. And pen turners, my God, they put that thing right in jail. Okay, so all we're going to do here, we're going to use a spindle roughing gouge, and we're going to rough this right down. That's getting close.
Can you test it in the back of the table?
I can. Yep, you can test this. I use my fingers up here, but I also go more by sound. Now, the next thing we need to do is this pummel cut right here. And they too are actually quite easy. I used to be really intimidated by pummel cuts, but I sort of got over that. We're going to go with a 1/4 inch. That's what we had for this particular job that I was working on. And unlike putting a line like I did where the skirt is going to end, I usually just do here and here because I want it to show up, but I want it to be a little bit different. It's a little lighter. Not much, but a little bit. But it does make a difference on some woods. Okay, now a pummel cut is actually quite simple. You can do them with any tool. And just a word here, this is a bowl gouge. I could use a spindle gouge if I wanted to, but I really don't get hung up on, this is my bowl gouge and this is my spindle gouge. Unless you look in the catalog, I don't know which is which. As far as I'm concerned, if it'll do the job, that's what I want. And as a matter of fact, I use a bowl gouge this is a 1/2 inch bowl gouge. I use a 5/8 bowl gouge to do most of my large newels, to do the cuts. But we're just going to lay that tool on there, and we're not going to get any tear out or anything, because we're just going to let the tip of the tool hit and then just ride it in. So my job now, when I get back here, is going to be, I want the top or point of this pummel to be back here, and then I want it to be round at that point right there. So I'm just gonna, basically those two lines you see on there, I'm just gonna connect those two lines. And this is very typical of how I do it. I don't try to do the pummel cut with the roughing gouge. I leave myself a little bit of room, and then I make several passes just to get myself in tune with where I want to actually be. Like, if I stop right now, this tells me what my pummel is going to look like, because I'm a little bit away from the point here, and I'm quite a bit away from here. So that means I want that to be just a little bit steeper. And it's amazing, after you do a couple of these, you can get this right on the money. Just like that. I could take that, maybe I should go just a tad bit steeper. Right there. I like that pretty much. Okay? So, right there to right there, and then they're all going to be the same, all the way around. Luckily for these legs, they're probably not going to be close together, so we're in good shape. Now, the other thing about a pummel cut is, you always want to go below the surface of the square, because what happens is, if when you're in final assembly, we do some sanding here, we don't want a flat spot our spindle here. So we always want to leave a little bit, even if it's only like a 32nd of an inch. Sometimes the plans will call for a good 1/16 of an inch step right there or something like that. That's nice. But in other circumstances, we're going to make sure that we've got that right down there. Pummel cuts. This was an exercise in pummel cuts. When I was going over, getting ready to do this, I thought I would show this, I'll pass it around, if I can just get right to that board right there. I happened to come, because I said I was doing, I did this demo, I came across this design that I had done some time ago. And so I grabbed a piece of black walnut, and I said, well, maybe I'll just have this to hand around so that nobody will be watching me here. You're looking at this. And this was going great. I had this all turned. I went to take it off the lathe Sunday afternoon. I'll be damned if I didn't drop it and took a chip right out of it. Taking it off. But this is basically the same thing with the layout. Okay, this is my original centers right here. And now I'm going to have offsets. And this is obviously larger and everything, but I used a 3/8 offset for each one of these. And to turn this, I used the old Dale Nish method. When I first started turning, there was a book called Creative Wood Turning. It was one of the first sort of books on wood turning. Came out in the early 1980s, and boy, it was the Bible. But back then we didn't have 4-jaw chucks and all this other gobbledygook. So the way that people turned was you took a waste block and you could screw it to your faceplate, and the example he used was turning a goblet, not an offset one, just a straight goblet. And basically you would turn a recess in here, put this between centers and turn a tenon on it and glue it in. And that's how I made this one. But then I just drilled 3 holes, and I turned this using a screw chuck. This was screwed onto the faceplate, and because in a turning like this, and many others, you're going back and forth and back and forth. The same thing here, actually. So that just turns on there, and you can actually see the marks on the bottom, but this is for the main center, and then I've got a 3/8 offset, and then a 3/8 offset. Again, one of the things that I really, really enjoy about turning is trying to problem solve. And in this case, the problem is, if I put this on a faceplate, I've got this thing dangling out here, and it's offset and it's wobbling, I don't stand a snowball's chance. of holding on to this. So basically, what I did is I just turned this piece that fits extraordinarily snug on there, and you can actually see, if you look, there's my original, when I turned this disc, I used the same screw chuck, but then I brought my tailstock in. Those are my two tailstock holes, so that this thing will stay on center. But it's a fun little project,
Charlie,
doesn't amount to anything.
which one of those stacks would you turn first?
First is the goblet itself, this and this. Okay, and so that you get this one and this one right here.
Yeah.
Okay, yep. And then you work out, you do these two, and this rascal's last. Yep. But what made me laugh about that was I said, you know, if you can, a lot of people get intimidated by this simple thing like a pummel cut. They say, well, they're going to tear out and all this bunch of stuff. Just remember that this is like that whole bundle of straws thing. So as long as we start high and go down, we're not going to get any chip out. It's just not going to happen. We can do a pummel cut anywhere along here. Okay? So I'll keep turning. Make sure I turn this back up. We'll get this just roughed down. Doesn't matter in here too much because that's all going to be smaller anyway. Just make me feel good. Right in here is where I want to make sure that I get that down to that 1.5 inches. Okay. Now what I'm going to do is I'm going to from the drawing that I have, I know that from right here to right here is a 1/2 inch. That's the height of the tip of this little turning right here. Okay? Now, just as an alternative, well, let me back up. The reason that I leave 1/8 of an inch right here on the end is for leveling the table once it gets made. That gives an extra 1/8 of an inch so that that's going to be cut off, and actually on this table 3/8 of an inch. 24.5 inches is my rough length. The actual length of this leg finished is 24 inches. But he's got 3/8 of an inch up here and 1/8 of an inch here. Ideally, those are all going to be cut off equal on all the legs. But if one happens to be a little bit shy, you can leave that and leave it, you know, a 30-second or so, and then that can be blended into the foot. So basically what I want to do is I want to come up 5/8 of an inch right here. And that's going to be the top of that foot. And what I'm going to do, just so I can, I'm going to actually shape the bottom of this foot right here when I come back. But I am going to start it so that when I offset, I have a little bit of something to go by. So I'm just going to round that just a little bit, just to get an idea of what that foot's going to look like. Now the reason I've got to leave that big is because I'm going to offset that. That center is going to be moved out. So I don't want to turn this down to 3/4 of an inch and then offset, and half of my drive center here is going to be not holding anything. I'll show you that when we back up. So now what we're going to do is we're going to do the famous offset. So we're going to put this over here, and we're going to put this over here, and here's my, make sure I get that out. Bob, we may need a little prayer here. No. Okay, so here we go. I'm basically a chicken, so I'm gonna slow this down. Now, as I bring the speed up, I know those of you right here, you can see the leg right there. So all I've got to do is turn this down to that diameter right there. Right here, that's 3/4 of an inch, right there. That's why I say, these are actually pretty easy because you don't need calipers or nothing. Now, one of the things that we've done and we need to check on, and it's pretty darn good, right here, right at that 5.5 inch line, that's running really true right there. So that's the payoff of that. That would literally be off at least a 1/16 of an inch if we hadn't done that offset on this end. So, I'm going to shut this off, get my tool rest in here. This is that thing, you know, they tell you, always rotate your stock 360 degrees. This is why, right here. Carl, you probably know all about that, right? Been there and done that? Okay. So what we're going to do now is we're going to form the actual spoon section right here, which is basically sort of like doing a pommel cut here. But again, I wouldn't go to the line. I'm going to go to within about maybe 1/4 inch of the line and work that right away. Piece of cake. We'll work that right in and around. Sometimes what I'll have to do with any type of a turning like this, sometimes I'll have to put a piece of white paper down here so that you can actually see a difference here. But you can see that we're starting to get the top of that foot. And we just need now to turn this down to the 3/4 of an inch. And we go by the back side of the foot right there. That's going to tell us, this is going to be the indicator of the 3/4 inch diameter here. Which is one of the other things about turning furniture legs and stair balusters and all of that stuff, that everybody, when they first start out, gets their knickers in a knot about diameters. And diameters don't amount to squat. I can be off by a 1/16 of an inch in these legs. And it might show a little bit, but it's not going to show bad at all. What's important is where things are here. If you've got one of these that's off by a 1/16 of an inch, that's what people are going to pick up on. So we've got a bunch of leeway when it comes to actually turning these things. I'm going to switch to the rough and gouge. Sort of anticlimactic when you tell everybody all the little secrets. Because literally, there's nothing technical about this type of cutting here at all. I guess the only technical part we would say is to be able to see that nice curve. We want that spoon to be a nice curve. So we're going to start up here, and we're going to just go right in there. Make that a nice curve into this foot. Getting close. I'll tell you what, this is a piece of cake compared to bird's eye maple. Bird's eye maple doesn't like to turn into. Just take a look and see how we're getting. I purposely have stayed about a 1/16 of an inch away from here, and I've got probably about another 1/8 of an inch or so. This is probably, if we measured that now, that's probably about 7/8. But I've got the roughing part down now, so I'm not, I thought I was. I actually, in my shop, this one, I guess this number's still here. But of all the tools I have, and I've over the years, you know, every time somebody comes out with a new tool, I've got to have it. This tool, according to my sharpening jig, this is number 1 and this is number 2. And I don't even have a number 3. 1/2-inch bolt gouge, 3/8 spindle gouge. I can do just about anything that you might want to do with it. Just come right around there. I believe we're just about at the line. A little bit further down. Check. Yeah, we got just a little teeny bit of flat right there. And another one of the options that they talk about, I made this one in the layout so that the back of the foot was actually tangent to my 1.5" diameter here. So that this leg comes down and it's going to be flat and continuous. By no means it doesn't have to be. Sometimes you can do that offset. I could offset this, this is offset 3/8, offset it 1/4 of an inch, take this down, and you get a little bit of a heel back here. So all sorts of options. It's all about that layout. And you know, in a lot of that work, I tell people that one of the major differences between spindle turning and bowl turning, first of all, spindle turning is much, much easier because you're going with face grain, so you don't have any end grain. The only end grain I've got is this little bit right here, and I can handle that. Secondly, the big difference is most spindle turning, you have to do some type of a layout. You gotta figure out where you are. Whereas bowl turner, who's gonna know the difference, right? Well, I'm not telling you. Okay, so I'm gonna come in here. I want to take that down just a little bit more, so I'm gonna ride that bevel right around that circle. And then go in there, I think we have a winner. So now it's a piece of cake. Just from there to there, I've got to turn it down to whatever my offset tells me to do. Bad. I always work detail-wise from the tailstock to the headstock. And I don't care if you're turning a Christmas ornament or you're turning a leg like this. By doing this, you've always got to remember, this is where the drive is taking place. So all of this wood down here is just riding, basically. It's not getting any twisting action to it. But this is where the drive is. So, you know, getting those long finials on a Christmas ornament or something, just remember, start at the point and work towards the headstock or where the drive piece is. If you do that, eliminate half of your problem. Boy, I'm going to, probably next month, we're going to have tables all over. I can only hope. Or maybe a candlestick or something. Using this idea. So I'm just going to finish that. And yeah, that came in there very nicely. I'm pretty happy. Now, I don't want to take much off here at all. I just need to finish this up. And we'll just finish that over. You can kind of feel that difference. And I've got one little bump right there.
You do a final cut for the skew?
No. This is a skew right here.
So it's not sandpaper.
Yeah, I take a piece of, use a full width of sandpaper now. It's amazing the bumps that you can feel just by your hand. Yeah, I would take a piece of sandpaper now because this is a straight taper and just, and now what we need to do is we'll go back to the original center and just finish up this leg here just a tad bit. And now what was the next piece is now the wobbly piece. So what we're going to do here is I just want to bring this in to about 3/4 of an inch. That's 3/4, I can tell. No, it's 13/16. And that leg looks like that leg. Now, some other applications of this, while I've got you right here, that I thought I would just give a show. You might say, well, geez, I don't want to make table legs. If you understand the principle here, we can get into doing some pretty funky things with a baseball bat. You know, anybody can turn a baseball bat. That's the easy part. But how can we alter a baseball bat to, now this is a simple parallel offset. So we just turn the baseball bat, this part of it, turn the regular barrel, 2.5, 2 5/8, whatever you want here, leave this alone, then offset. The offset process, and I don't know, I'm just going to look this quickly if I can. Yes. I did have this. Again, this happens to be the sketch for this. These all have sketches that go with them. But this is the sketch of this one here. These are all just the prototypes. These aren't the finished pieces that we did. But when I was here at the college, we had, you know, the baseball team. They were turning these things like crazy. They'd burn this. You know, we actually took a baseball apart so that we could use the outside casing to lay on here and lay out the burning of the laces and everything. But this is a piece of cake. This is not hard to do as long as we understand the offsets here. As I said, this one is a parallel offset, but to determine this offset, and I guess I didn't have it here, but I do the same thing. You take a look at the end of the piece and you just say, okay, in this case, the question is going to be, how far can I offset this? And the answer is, if you draw a circle as big as the piece of wood you have, this started as a 4x4, and you put this off to one side, and then you put this second diameter down here at the largest point, push it over as far as you can, to the 3.5 inches, whatever it is, that determines your offset. And as I said, this happens to be a parallel offset. This was actually the first one of these offset bats I ever turned. This is just a piece of 4x4.